Hi everyone, if you want to revise the whole of integration, mastering with all the type of questions, you are in the right place. And this video series will help you to achieve that. Check it out. Hi everyone, this is our 10th video tutorial in integration, and this is the last video tutorial to explain what is the last section of this integration. So far you have built up your knowledge by learning each and every pattern of the questions. So when you see a pattern, you know exactly what sort of formula you need to apply, or what sort of like a trigonometry identity or other means of doing questions. Now in this question, there are two different functions are going to be as a product combined together. So when you see this pattern, you need to be identify who is who and who is the other functions we are going to be assigned. We call this as an integration by parts. So when integration by parts, like I'm not going to be proving the theory is in the format of pattern 23, right? A function is integrated u times dv over dx. Integrating with respect to dx can be written as u times v minus integration of v du over dx, right? This formula is coming from straight away from your product rule of your differentiation from your calculus topic, right? So reverse to that one, when you are integrating two functions, let me change the color and explain. So if two functions, u is one of the function and dv over dx is the second function, they are in the product times together, and we are integrating with respect to x. The answer is u times v minus v du by dx. Now the formula is ready. Maybe that formula is given in the formula book also. Now my problem, who is u, who is dv by dx, right? So this is the trick you need to learn. For a shortcut patterns, I'm putting a star mark here. This is the very useful tool. It's called ILET, right? ILET, I stand for inverse trig function, L stand for logarithm functions, A stand for any algebraic function, and T stand for trigonometric function, and E stand for exponential function, right? So you watch out what is the question and which patterns this fall into, and you need to assign. If I draw a line on my right hand side, the function is dv over dx, right? And this side is going to be u, right? What is that? For an example, L and A, a logarithm function and A means algebraic functions combined together. So L becomes the u, A becomes the dv by dx, right? Let's say if it is algebraic function and the exponential function near to the dv by dx, so exponential function become dv by dx and algebraic function becomes the u, right? So let's do the question and show you how to do this one. For an example, my first example, it's not in the question list. I'm going to do this question, x e to the power x dx, and that is the question. Now, by looking at the question, you must understand that is integration by parts. Integration by parts. So I'm underlining this function is algebraic function and this function is exponential function. What does that mean? E means exponential function near to the dv by dx. So my e to the power x, I am going to be assigned that as a dv over dx, right? And now algebraic function is closer to u, so my u is x, right? Now the idea is when you differentiate du over dx, that is 1. And now integrate the both sides. So that means dv I'm integrating with respect to integrating e to the power x dx. And now from that you find out v equal e to the power x, right? So I'm underlining we found the v function and we know the u function. Now I'm going to be writing the question as x e to the power x dx equal to, the answer is u times v. You can directly apply u times v, which is x e to the power x minus integration of v, which is e to the power x, du over dx is 1 dx. 1, you don't need to write. So the answer is x e to the power x minus integration of e to the power x is e to the power x plus c. And now that is the formula. We applied, and that is the answer for the example 1, right? By having this question number 1 done, I'm going to be continue with my second question as an example, integrating x squared e to the power x dx. That is my second example. Now, if you do a couple of questions by experience, you will figure it out. When the x squared comes, the integration by parts, you have to do it 2 times, right? Let me have a look. Now, this x squared is my algebra, and this e to the power x exponential. Now, we know exactly what to do. U as in x squared, because u is algebra, and exponential function is dv by dx is the e to the power x. Now we are going to be differentiate the u function, which is du over dx, which is 2x, and integrate, get v equal e to the power x. You know exactly how to do that one. So now integrating x squared e to the power x dx, that is equal to u times v. U times v is x squared e to the power x minus v times e to the power x times du by dx, which is 2x dx, right? I'm going to write this one here separately. X squared e to the power x minus, the 2 is a constant, I'm taking it out, integrating e to the power x, or you can write as a x e to the power x e to the power x dx. So that is what we ended up with. Now this is the question we already done. That is the first example I did. So you need to do the integration by parts separately. For that answer we already know x squared, I'm not going to be do that again, minus 2 in bracket, the answer is x e to the power x minus e to the power x and plus c. And final answer is going to be x squared e to the power x minus 2x e to the power x plus 2 e to the power x plus c. And now what we learned is now integration by parts, normal question, and if you need it, you need to do twice the time and you will get the second time the integration and you will get the answer. So now I'm going to take off everything, all the example. Hope you understand. So I leave the formula written on the top. So making sure, or I can take it off because the formula is already in the yellow color short notes tutorial. Let's start with the one by one the question, right? The first question we are going to do integrating x cos x dx. Now, by looking at the question, this is integration by parts. Why it is integration by parts? Because x is a algebraic function and cos x is a trigonometric function. A and t, look at the order A and t. T is closer to dv by dx, A is u. So algebra becomes the u and trigonometric function become the dv over dx is cos, right? Now differentiate du over dx, that is 1, and integrate both sides, and you will get v. So you can show the working out like a dv, you are integrating, and you are integrating cos x dx. Integrating cos x is sin x, so v becomes the sin x. Now integration of x cos x dx equal u times v, so x sin x minus integration v as in sin x du by dx is 1, then dx, then x equal x sin x minus integration of sin x is minus cos x, so that becomes plus cos x plus c, and that is the answer for the question number 1. So let's do the question number 2 as well. Integrating x sin x dx, so algebra and trigonometry involved, so u equal x, and dv over dx is equal to sin x, and from that you can integrate dv, and that is equal to integrating sin x dx. Right? Now du over dx is equal to 1, and if you integrate v equal integrating sin x is minus cos x, right? So that is the answer, and now you can write the formula. X sin x is the integration dx, that is equal to u times v, so u x times v is minus x cos x minus integration of v, which is minus cos x, times du over dx is 1 times dx. So that minus going to be multiplied by the outside, so minus x cos x plus integration of cos x dx. So the answer is minus x cos x, integration of cos x is going to be sin x. So plus sin x plus c, and that is the answer for question number 2. So now you understand integration by parts, how to do the assignment, who is u, who is dv by dx, and carry on working on that one. So question number 3, integration of x ln x dx. Now you know that x is the algebra, ln x is the logarithm. So if you look at the diagram, ln x becomes the u, right? Careful, u becomes the ln x, and dv over dx becomes the x, right? So du over dx is ln x differentiation is 1 over x, and if you integrate the dv, you can show the working out, integrate of dv, integrate of x dx, that becomes x squared over 2. So that is x squared over 2. So now we are going to write x ln x dx, that is equal to u times v, u is ln x, so v is x squared over 2 ln x, minus integration of v, v as in x squared over 2, du over dx is 1 over x dx. So if you keep on doing that, x squared over 2, so let me quickly take that line away, x squared over 2 ln x. Now x squared and x cancel, so minus half outside, and integrating x dx, right? And that answer will give x squared over 2 ln x minus half x squared over 4. So that x squared over 2 times by the half, so I will write the formula straight away, minus x squared over 4 plus c, and that is the answer for that question, right? Careful with all the steps. And now I'm going to do the question number 4, because there's a connection between the question number 3 and the question number 4. Now the question number 4 is integrating x squared ln x. So the principle wise, like the concept is same. So this is the logarithm function, and this is the algebraic function. So you need to assign the logarithm function as u equal ln x, and dv over dx as x squared, and now integrating x squared dx, and now that gives v equal x cube over 3, right? Now du over dx, it's going to be 1 over x. Now you can write the formula, integrating x squared ln x dx is equal to u times v. U times v is x cube over 3 ln x minus integration of v du over dx. So x cube over 3 du over dx is 1 over x dx. That answer will come as a x cube over 3 ln x, right, minus 1/3 integration of x squared dx, right? And now you can easily find out the answer as x cube over 3 ln x, right, minus x cube over 3 times by 3 x cube over 9 plus c. And that is the question number 4. And question number 4, everyone, done. And now question number 5, it's a very famous question in integration, right? There is no clue given what type, and you need to understand that is integration by parts. So integrating just ln x, a very famous question, just ln x dx, and there is no other means of doing this question. You need to consider there is a 1 times ln x, right? And now you need to use this as your logarithm function, become u, and this 1 as a, you can assign that as a kind of algebraic function, right? It's no x term, so there's a number and algebra term, so that becomes your dv over dx, right? Now let's start with the question, u equal ln x, and now du over dx becomes 1 over x, and now dv over dx becomes 1. Now dv equal dx. Now you integrating both sides becomes v equal x, right? Now that answer is u times v, which is x ln x, minus integration of v du over dx, which is 1 over x dx. X and x cancel, so the answer is x ln x minus integration of 1 dx. That answer we all know, x ln x minus x plus c, and that is the answer for integrating ln x. One more question, that is the end of the integration series of tutorial, and after that in another tutorial we are going to go through all the past paper related questions in integration, right? So question number 6, in the question number 6, integrating 2x squared sine 2x dx. Now sine 2x is the trig function and 2x squared is the algebraic function. So when you look at this one, you immediately know algebraic function becomes the u. So u becomes the algebraic function because algebraic function near to the u, so u equal 2x squared, and trigonometric function, which is the dv over dx, becomes the sine 2x. That's all you need to do, right? Rest is easy. So du over dx, right? So 4x, and integration of dv sine 2x dx, and you integrating both sides, and that becomes v equal, right? Now integrating sine x is minus cos 2x divided by 2. So you need to keep that in mind. So answer is u times v. So u times v means u is 2x squared, v is minus cos 2x divided by 2 minus integrating v, which is minus cos 2x over 2 du over dx. Du over dx is 4x, right? Dx. Now, if you write this answer nicely, that 2 and 2 cancel. So minus x squared cos 2x, minus time minus is plus, and 2 and 4 cancel. So the answer, the 2 coming outside, integrating x cos 2x dx, right? So that is the intermediate step. I'm going to use a different color. I'm circling. I'm going to do this question separately. Again, another integration by parts, right? So this is the algebra and this is the trigonometry, right? So from that algebra, I'm going to be assign that as a u. So my now u is in x. So du over dx is 1. And now dv over dx is now cos 2x. From that you integrate and find out sine 2x over 2. That is the v we already found. Now for that particular question we find the answer u times v. So x times sine 2x over 2 minus integrating v, which is sine 2x over 2, du over dx is 1 and dx, right? And now that is the answer. And now if you integrate that answer, the answer is x sine 2x over 2 minus integration of sine x is minus cos 2x over 2. So that becomes plus cos 2x over 2. There's a 2 times 2 is 4. So that is the answer for this part, the one I'm putting star mark. So the final answer for the question is, we already got an answer minus x squared. Let me write that nicely. Minus x squared cos 2x, right? Plus 2 times, it's going to be x sine 2x, x sine 2x over 2 plus cos 2x over 4 plus c, right? And that is the answer. You can expand the bracket and leave it as long as you understand the concept, how the things work, and that's it. So that is the end of the integration 10 tutorial series. Please watch out carefully and making sure you understand the patterns of integration, and wish you all the best for your exams and making sure you do this question. So if you do the integration in your exam, you're having 3 to 4 questions, integration related questions. And we're going to do one more tutorial with all the past papers with the integration, how to handle the integration question in the past paper. And that tutorial is going to be a membership feed tutorial. So you need to become a member to our Smart Tutors YouTube channel to access that past paper tutorial. I hope you like the video. If you like the video, please click the like button and subscribe to our channel to see all the upcoming videos. And that's it. I wish you all the best. Bye now. Thank you. Bye.